With the trigonometric identities. And for trigonometric identities, what we'll do is we'll use this triangle ABC, which is 90 degrees at B. Now, what is an identity? Identity is something equation which is true for all values of the variable. So let's see what are the trigonometric identities. These trigonometric identities are also known as square relations, because in this we'll have squares of the trigonometric functions. So let's start off with this triangle. Let's apply Pythagoras theorem. So if you apply Pythagoras theorem, you'll have AC square is equal to AB square plus BC square. Now you divide, you give this name as name of this equation as 1, and you divide both sides of this equation by AC square. So what you'll get 1 equal to, you'll get AB upon AC the whole square plus BC upon AC the whole square. Now this is 1 equal to AB upon AC. So AB upon AC. So if you watch this closely, AB upon AC is sine of theta, because sine theta is opposite upon hypotenuse. So this is actually sine square theta plus BC upon AC. BC is adjacent, AC is hypotenuse, so this is cos theta. So this is cos square theta. So this is your first identity. It is true for all values of theta, and therefore it is known as identity. Example, sine square 60 plus cos square 60 is 1. Sine square 45 plus cos square 45 is 1. This is the first identity. Let's check the second one. Now this equation 1 you divide by AB square. So what you'll get AC upon AB the whole square equal to AB upon AB, which is 1, plus BC upon AB the whole square. Now AC upon AB. So AC is hypotenuse and AB is opposite. So this is actually cosec square theta equal to 1 plus BC upon AB. BC is adjacent, AB is opposite. So this is actually cot square theta. So you get the second identity, 1 plus cot square is equal to cosec square. The third one, you divide equation 1 by BC square. So what you get is AC upon BC the whole square equal to AB upon BC the whole square plus BC upon BC, which is 1, AC upon BC. So AC upon BC. So that is hypotenuse upon adjacent, which is sec square, and this would be AB upon BC. AB is opposite, BC is adjacent, so this is tan square plus 1. So these are the three trigonometric identities. Now, how do we use these identities? So sine square plus cos square is 1. So you can use this as this way. You can say sine square theta is equal to 1 minus cos square, depending upon the question. Or you can say this is 1 square minus cos square. So I can write this as 1 minus cos into 1 plus cos. This is the formula of a square minus b square. So that means you can use this identity in various forms. You can say cos square theta is 1 minus sine square theta. And similarly, you can write this as 1 minus sine theta into 1 plus sine theta. Then you can use this one, this identity, this one. You can write this as cot square, or you can write this one as cosec square minus cot square equal to 1. I can also write this as cosec theta minus cot theta into cosec theta plus cot theta equal to 1. So I can also write this as cosec theta plus cot theta is equal to 1 upon cosec theta minus cot theta. So these are different ways by which you can go ahead and use the identities. You can do similar things with this one, the third identity. So again, this one, seeing this, you can just easily write this one as, you can say this is sec square minus tan square is equal to 1. Then I can write sec theta minus tan theta into sec plus tan. This is also equal to 1. And I can say sec minus tan is equal to 1 upon sec plus tan. So depending upon the sum, we can manipulate these identities and use it to our advantage, right? So these are the trigonometric identities, and you don't need to memorize all these manipulations. These are just, you can just play around with these identities, and you can get these formulas, and we'll use it according to the sum, right? So we can just take one small example, and then we can see the rest of the sums in the next lecture. So if we just take one simple example, and let's see how we can apply the trigonometric identities. So let's take one example which says, let's say you have the question as prove tan of A plus cot of A is equal to sec A into cosec A. So what I'll do is I'll take the left hand side, and tan I can write as sine A upon cos A. Cot I can write as cos A upon sine A. I can take the LCM, so I'll get sine square A plus cos square A upon sine A cos A. Sine square plus cos square we know is 1. So I can write this as 1 upon sine A cos A. And we need this as the answer. So 1 upon sine is cosec, 1 upon cos is sec. So I can write this as sec A into cosec A, which is our right hand side. So this way we can use the identities. We don't need to memorize any of them. We can just derive it using Pythagoras theorem, and you can just play around with these identities in the sums. So in the next lecture, we'll see in detail the questions which involve trigonometric identities. Till then, guys, take care. Bye bye.